The developers of the TSI at Volkswagen have created an extraordinary engine. It's a compact engine delivering a power output of 125 kilowatt and 240 Newton meters torque and fuel consumption of 39.5 miles per gallon. The engine design concept is optimized to reach maximum torque at low revs and to deliver it over a wide rev range. Conventional large engines come quite close to this goal. They stand for driving pleasure and comfort. The challenge for this development project was to combine large engine driving enjoyment with the economic advantages of small engines. The engine achieves optimum fuel delivery by injecting fuel at 150 bar via new 6-hole injectors directly into the combustion chambers. The FSI combustion process takes advantage of the evaporation cooling effect to allow a high compression ratio of 10:1. Previously, engines with high charge pressures had one limitation. The low exhaust energy at low revs causes so-called turbo lag. This is where dual charging comes into play. Volkswagen engineers have added a second charging component before the turbocharger, a high-speed, mechanically driven compressor. This effectively eliminates turbo lag. When high torque is demanded in the lower rev range, the compressor runs continuously. Dynamic compressor operation marks the transition to turbocharger operation. The schematic shows the air intake in the engine. Here you see the process at idling speed. If the driver now demands high power via the accelerator, the compressor is activated. An electromagnetic coupling, which is integrated into the coolant pump unit, connects and disconnects the compressor. A high transmission ratio enables the compressor to already deliver a pressure of up to 1.8 bar at idling revs. That means that the engine can, even when just pulling away, already deliver the desired high torque. In permanent operation, a high load demand will cause the control flap to close and the entire intake airflow will pass through the compressor. The compressor's high rotor speed has optimized engine responsiveness. In dynamic compressor operation, the automatic charge pressure control system determines, depending on the power demand, whether to activate the compressor or whether the turbocharger alone can supply the required charge pressure. If the charge pressure from the turbocharger is sufficient, the control flap opens and allows the direct passage of air to the turbocharger. When the engine revs drop back into the lower range and then power is demanded again, the engine management responds immediately. The compressor is activated again. The control flap closes, thus passing the air via the compressor. Above 3,500 RPM, the turbocharger switches to unassisted operation. When high power is requested, for instance when traveling at high speed, the turbocharger supplies sufficient pressure. Thanks to the use of high temperature resistant materials, its fuel economy is outstanding, even at high vehicle speeds. Comparisons with other A-segment engines clearly show that the two development objectives have been fully achieved. An engine with high dynamic performance which, relative to its power output of 125 kilowatt, is extremely economical. Over 250 prototypes and pre-production engines have been put through their paces in all required test cycles. Thus, Volkswagen's high-quality standard fully applies to this engine, built in Chemnitz. Driving enjoyment and economy, a successful combination realized with the high level of engineering you've come to expect from Volkswagen. That's why the Golf GT, powered by the TSI engine, is one of tomorrow's generation of cars.